first problem, we're supposed to solve a rational equation. So what we need to do is get rid of the fractions. And so multiply every single term by x minus 3 times x plus 2. So when I multiply this by that, the x plus 2's cancel, and I'm left over with 3 times x minus 3. When I multiply this by what's on the outside here, the x minus 3's cancel, and I'm left with 4 times x plus 2. And when I multiply this fraction by what's on the outside, everything cancels there, and I'm left with that. And so I'll have that. And now I need to gather like terms, so I'm going to have 7x minus 1 is equal to 5x minus 7. I'm going to subtract 5x from both sides. So I'm going to get 2x minus 1 is equal to negative 7, and I'm going to add 1 to both sides. And dividing both sides by 2 gives me x equals negative 3. Now, before I say that's the answer, I need to go back and make sure it's allowed. And if x is negative 3, it's okay here, because that'll make this negative 1. And if x is negative 3, it's okay here, because it'll make that negative 6. So as long as it doesn't make the denominator 0, it's allowed, it's in the domain, and so my answer is going to be x is equal to negative 3. Okay. And so I'm going to type in C. Okay. All right, I'm going to do the same thing. I'm going to multiply everything by x plus 1 times x plus 6. So I'm going to have this fraction plus this one is equal to this one. So those will cancel, and I'll be left with that. And those will be canceled, and I'll be left with that. And all of that cancels, and I'm left with 5x plus 13 over here. Then I have to distribute the 3. I have to distribute the 4 through. That's going to give me 7x. That's going to give me 27. Subtract 5x from both sides. And then subtract 27 from both sides. So that's going to be negative 14. So I'm going to have 2x is equal to negative 14, and divide both sides by 2, and I get x is equal to negative 7. Now, before I say that's the answer, I just check negative 7 is allowed, that it doesn't make the denominator 0. So negative 7 here is going to make that negative 1. That's fine. That becomes negative 6. That's fine. Okay, so negative 7 is allowed. And I'm going to be getting D. D. Okay. All right, let's go to question 3. Let's solve for x. Okay. Well, what I can see here is x squared minus 2x is the same as that. So let's multiply everything by every term by x times x minus 2. So those will cancel and on this side, and so I'm going to be getting equals -2. And then when I multiply this one by x times x minus 2, the x minus 2's cancel, and I'll be getting 3x plus 2 all times x, all of that times x. And then when I take this one and multiply it by x times x minus 2, the x will cancel, and I'm going to be left with x minus 2. Okay, now distributing the x, I'm going to have 3x squared plus 2x plus x minus 2 is equal to -2. So I'm going to have 3x squared plus 3x. And then I'm going to, this is a quadratic, I can solve a quadratic if it's equal to 0. So I'm going to add 2 on both sides. So that cancels and that cancels. And I have that. Now I can factor out a 3 and an x. So I'll be left with x and then plus 1. So I have two possibilities for this equation. If x is 0, that'll make the entire thing 0. And if x is -1, that'll make the entire thing 0. But I just have to go back and check that it's allowed in the original equation. So if x is 0, then it's not allowed here because that would give me 1 over 0. So this is actually an extraneous solution. So that's not allowed as a general solution. But x equals -1 should be just fine. If x is -1, that becomes -3, which is good. That becomes -1, which is fine. That becomes -1 squared minus 2 times -1, which will be 1 plus 2, which is +3. So we don't get 0 on the bottom anywhere if x is -1. So I had to reject 0, but -1 is my answer, and we can see that that will be E. I'm going to come over here and type in E. Okay. Let's look at this one. Well, this is the same as, I can factor out an x, and I'll have that. So I'm going to multiply every term by x times x plus 2. Okay, so when I multiply the first fraction by this, the x's will cancel, and I'll be left with that. When I multiply the second fraction by this, the x plus 2's will cancel, and I'll be left with x times x, which is x squared, equals, and then when I multiply this one by that, everything cancels there, and I'm left with 4. Distribute the 3 through. All right, so I'm going to lead with my x squared, then plus 3x, and then I'm going to subtract 4 from both sides, because I can solve a quadratic if it's equal to 0. So 6 minus 4 is 2, and 4 minus 4 here is 0. Now, to solve that, I can try and factor it. Two numbers that multiply together to give me 2, but add up together to give me 3. Well, 2 and 1. So I can see that my solutions here are going to be -2 and -1. But are they allowed in the original equation? If x is -2, we're okay here. If x is -2, we're not okay here. because negative 2 plus 2 is 0. So negative 2 is extraneous. It was a solution to this, but it's not allowed in the main, in the original equation. Now, what about if x is equal to negative 1? It's allowed there, and negative 1 plus 2 is positive 1, so it's allowed there. And what about here? I'd get in the denominator that, so I'd get positive 1 minus 2, which is negative 1. So that's allowed, and my answer is just negative 1 on its own. So I'm going to type in C. Okay. Now let's look at number 5. You're supposed to only write that with positive exponents. Okay, well, for these parentheses, and we have a product inside, what's on the outside gets applied to everything separately inside. Now, if you have something to a negative power, that's the same as 1 over that to, and get rid of the negative sign. And this is the same thing as 1 over x squared. And so I'm going to have 1 over 25 times 1 over x squared. And when you're multiplying fractions together, you multiply the tops and multiply the bottoms. And so in the denominator, we're going to have 25x squared. So that's the one we want for that one. And the answer is D. Okay. All righty, let's keep going. All right, you're supposed to only express that with positive exponents. So using the exponent rules, this is equal to m to the power of, and we add all of those. So it's going to be n minus 9 plus 5 minus 1, which will be n to the negative 10 plus 5, which will be that. So when you add those up together, you get negative 5. And if I want to write that without the negative sign, the process is you do 1 over. And so that's going to be our answer. And so I'm going to type in A for that one. Okay. And get rid of that. And scroll down. All right. Now, we have a rule that says if you have the same base, and the base here is x, that's equal to x to the power of a minus b. So if I have this over that, it's going to be x to the power of the exponent in the numerator minus the exponent in the denominator. And that's going to be x to the minus 20th. And then to write it with only positive exponents, it's going to be 1 over x to the 20th. So that's the one we want. So I'm going to write B. Okay, so let's keep going. All right, let's see what's going on here. Let's look at the numerator. Well, we've got a product inside here, so this 3, this power 3 gets applied to everything separately. So I'm going to have 2 cubed times r to the 4th all cubed. It's going to give me 8. And now the rule here is we have r to the 4th all cubed. You're going to multiply, and 4 times 3 is 12. So that's my numerator. And then my denominator, well, I have the 3 outside the front, and then the rule here is you multiply and 3 times 2 is 6. Now you can split this up. It'll be the numbers and the power of r. Now 8/3, we can't do anything with that. That's as simplified as it gets. But here, the rule says it's going to be r to the exponent in the top minus the exponent in the bottom. That'll be r to the 6th. And then when you have a fraction times something that's not a fraction, it gets multiplied in the numerator. Okay, and that is matching up with this one, which is D. My answer is D. Okay, let's see what we have here. Okay. Well, the first thing I notice here, it's a square root of a fraction, and you can split that up into the square root of the numerator and square root of the denominator. And the square root of 25 is 5. So I'm going to have 5 as my denominator. Okay, so now let's look at the numerator. I can split that up. Now 18 is not a perfect square, but I can write 18 as 9 times 2. The square root of x squared is x, and square root of y, I can't do anything with that. Square root of 9 is 3. And then I'm going to swap the order now because this is a product. And then I'm going to put these together under one square root symbol. It's going to be 2y. So I'm going to, this is my numerator. And my denominator was 5. Okay, so I'm going to look for the one that looks like this, and it looks to be that one. So my answer is D. Okay, so again, it's a fraction, so I can write it up like that. And the square root of 25 is 5, so I'm going to have 5 in the denominator. Now in the numerator, I can split that up. Square root of 81 is 9. The square root of x squared is x, because we're assuming it's positive. And so that's the answer to this one. So I want A. Okay. All right, let's see. See if we can simplify this. All right. I can write that as the cubed root of 8 times the cubed root of x to the negative third times the cubed root of y to the 6th. Well, the cubed root of 8 is the number 2. And at any stage, you can rewrite a cubed root as a 1/3 power. So I might do that now with the rest of it. So that's equal to 2. And I'm going to write this as x to the negative third to the 1/3 power instead of cubed root. And this is the same as y to the 6th to the 1/3 power. Okay. Now the rule here is you multiply. and negative 3 times a third is negative 1. And the rule here is you multiply, and 6 times a third is 2. But none of these look like that. So x to the negative first is the same as 1 over x. And so if I'm multiplying a fraction by stuff that isn't a fraction, they get multiplied in the numerator. So 2 times 1 times y squared will be the numerator. And I'll have that. So I'm looking for that one, 2y squared over x. So my answer is B. Okay. All right, let's go down here to this one. All right, so again, I could rewrite this. To the 1/3 power. And so it applies to everything separately. Okay, 8 to the 1/3 is the cube root of 8 is 2. I multiply, 3 times a third is the first power, x to the first power, just x. I multiply, I'm going to get y to the negative 2. And that's going to be 2x times 1 over y squared, which will be 2x all over y squared. So my answer again is D. Okay, let's look at this one. Now I can split this up. Now 90 is not a perfect square, but I can rewrite 90 as 9 times 10. And the square root is the same as the 1/2 power. Now, yes, that's the same to the 1/2 power, but I'm going to have to do some more with that. So here I'm going to have square root of 9 is 3. Then we have times square root of 10. I can't break that one down anymore. If I multiply, 6 times 1/2 is 3. So I get m cubed. And now, if I multiply, I get 5 halves. So what I need to do here is to rewrite 5. So I can get an even number in there. So I'm going to rewrite that as n to the 4th times n. Now I'm going to bring the 3 and the m cubed out front. So I'm just changing the order there. And so that's m cubed. That's not the cubed root of 10. It's m cubed. All right. And then here, that'll be n to the 4th to the 1/2 power, and n to the 1/2 power. And 4 times 1/2 is 2. And n to the 1/2 is the square root of n. And now I'm going to bring 3m cubed times n squared times the square root of 10 times the square root of n. And then I'm going to put these together in one square root. Okay, that's what I'm looking for. And that's what we have there. So the answer is C. That's an actual final exam question from the previous year. Okay, let's keep going. Now let me come up here. And I'm going to have the 4th root of 486 times the 4th root of 10, p to the 10, my bad, times the 4th root of q to 11. Okay. Now, the 4th root of 486, let me check that. So I want to take 486 and raise it to the 1/4 power, because I don't have a fourth root command in my calculator. Okay, so that's not working out. Okay, it's not a perfect fourth root. Can I multiply it by something? 486, let me divide that by, let's see if it'll divide by 27. Yes, okay. That's not a fourth root. Okay, 27 times 3. Okay. 486 divided by 81. Okay. So this is going to be the fourth root of 81 times the fourth root of 6, because 486 is equal to 81 times 6. All right. Now, 10 is not a multiple of 4. So I might want to rewrite that as p to the 8th times p squared. And again, 11 is not a multiple of 4. So I might want to rewrite that as q to the 8th, because 8 is a multiple of 4 times q cubed. All right, 81 is 9 squared, but it's also 3 to the 4th. So the fourth root of 81 is 3. And fourth root of 6 can't do anything with that. And here, I might change these now to the 1/4 power. And same thing for that. Okay, so let's see what happens. And again, these are actual final exam questions. So this will be p to the 8th to the 1/4 times p squared to the 1/4 then times q to the 8th to the 1/4 then times q cubed to the 1/4. Okay. Now, if I multiply there, 8 times a fourth is 2. So I'm going to get p squared. If I multiply here, I'm going to get p to the power of 2/4. And I might, or this is just the fourth root of p squared. I might leave it like that now. Here, if I multiply, I'm going to get 8 times a fourth, which is 2. And here, I'm going to have the fourth root of q cubed. Because what I'm going to do is I'm going to combine all of my fourth roots together. So I'm going to have 3 out the front times p squared times q squared. And then I'm going to combine all of these fourth roots. 6 times p squared times q cubed. Okay. And now that's my answer. And which one does that match? So I need p squared and q squared. 3p squared q squared out the front, so it can't be that one, and it can't be that one. Then I want the fourth root of 6 times p squared q cubed. Okay, so it's not that one. So the only thing it can be is D. Matches D. Okay. Let's solve the radical equation. I am going to square both sides. So this side will be 25, and the square root and the square will undo each other, and I'll get that. And then subtract 3 from both sides. And I just need to go back and make sure it's allowed in the original equation. So 22 plus 3 is 25, and the square root of 25 is 5. So my answer is 22. Okay. And all right, what I'm going to do here is I'm going to add first this to both sides. So then I'm going to have, those will cancel out, and I'm going to have that. Now I'm going to square both sides. And so over here on the right, square root and a square will undo each other, and I'll get that. Be extremely careful here on the left. This is not 2x squared. This is 2 squared times x squared. Now, I can solve a quadratic if it's equal to 0. So I'm going to subtract 3x from both sides, and I'm going to subtract 1 from both sides. So over here, I will have 0, and over here, I'll have 4x squared minus 3x minus 1. Now, I can factor this. I can try to factor this, or I can use quadratic formula. When x is multiplied by something bigger than 1, I use quadratic formula. So a is equal to 4, b is equal to negative 3, and c is equal to negative 1. So my answers will be negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. And so that's going to give me positive 3 plus or minus the square root of positive 9, and these two negative signs cancel, plus 16. So that's going to be 25. And the square root of 25 is 5. So this will become 3 plus or minus 5 all over 8. So I'll either have 3 plus 5 over 8, which is 8 over 8, which is equal to 1. Or I'll have 3 minus 5 over 8, and that's going to be negative 2 over 8, which is negative 1/4. But I have to make sure it's allowed in the original equation. So if I put in positive 1, this will be 3 times 1, which is 3, plus 1, which is 4. So I'll have 2 times 1 minus the square root of 4, which will be 2 minus 2, which is 0. So 1 works. 1 is a solution. But what about negative 1/4? If I put this in the original equation, I'm going to have 2 times negative 1/4 minus the square root of 3 times negative 1/4 plus 1. So that's going to give me negative 2/4, or negative 1/2, minus the square root of negative 3/4 plus 1. And so I'm going to have negative 1/2 minus the square root of 1/4, which is going to be negative 1/2 minus 1/2, which will be negative 1. And that does not fit. That does not work. That is extraneous. I only have one solution, and it's x equals 1. So my answer is going to be C. Okay. All right, I'm going to square both sides of this one. So over here, I'm going to have 2x plus 19. Over here, I have to FOIL that. So I'm going to have 4x squared plus 14x plus 14x again, plus 49. And now I want to subtract 2x from both sides. and subtract 19 from both sides. So I'm going to have 4x squared plus 26x, so 28 minus 2x. And 49 minus 19 is 30. And I can divide everything by 2. And I can try the quadratic formula with that. A is 2, B is 13, and C is 15. And see what fits. So if I'm going to do that, I'm going to have minus B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Okay. So inside that square root symbol, the argument's going to be 13 squared minus 8 times 15. And that's going to give me 49. So the argument inside here is 49. So I'm going to have negative 13 plus or minus 7 all over 4. If it's plus 7, I'm going to have negative 6 over 4, which is negative 3/2. And if it's minus 7, I'm going to get negative 20 over 4, which is negative 5. Okay, now I need to test these. Okay, in the original equation. Now, if I'm negative 3/2, then the left-hand side is going to be equal to 4. And the right-hand side is going to be equal to 4. So negative 3/2 is definitely a solution. Now what about negative 5? Is that going to work? On the left-hand side, I'll have that, which will be negative 10 plus 7, which is negative 3. It's not going to work because the square root of a number is always defined to be the positive one. So negative 5 is extraneous, so I only have one solution, and it's negative 3/2. So that's going to be C. Okay. And let's see if we can solve this equation. How many questions have we actually got here? All right, that's a big. All right, so let's come here. If I square both sides, I'm going to have 3 minus 2x is equal to 1 minus 3x. Then I'm going to add 3x to both sides. And 3x minus 2x is x. And then subtract 3 from both sides. And x is equal to minus 2. Now, is that going to work? Well, over here on the left-hand side, I will have the square root of 3 minus 2 times negative 2, which will be the square root of 3 plus 4, which will be the square root of 7. And over here, I'm going to have the square root of 1 minus 3 times negative 2, which is going to be the square root of 1 plus 6, which is going to be the square root of 7. So it does work. And the answer is B. All right, solve this equation. Well, first thing I'm going to do is add 1 to both sides. And there are two solutions. We have that, or we have that. And solve these for x. Add 3 to both sides, and then divide both sides by 2. So 7/2 is one answer, and add 3 to both sides. Divide both sides by 2, and -1/2 is your other answer. And if we look at the original equation, if x is -1/2, then I have the absolute value of 2 times -1/2 minus 3 minus 1 on the left-hand side. So that's going to be -1 minus 3, which is going to be 4 minus 1, which is going to be 3. So that works. And if I have 7/2, I'll check it with that in there. 2 times 7/2 minus 3 minus 1 is equal to, well, the 2's will cancel. We'll have that, which is absolute value of 4 minus 1, which is 4 minus 1, which is 3. So they both work. -1/2 and 7/2. So C. The answer is C. Okay. I have to do a bit of fixing up first. I need to add 4 to both sides. And we will have 3 times that is equal to 10 plus 4 is 14. Then divide both sides by 3. And so I'm going to have that. Okay, now I'll have two cases. Okay, so add 1 to both sides. Let me do that up here. Okay, so I'm going to add 1 to both sides. I didn't start this test until like 15 minutes into it because I had a phone call. So I should be able to get an extra 15. So I'm going to add 1 to both sides and give myself an extra 15. So that's the same as that. And that'll give me 17/3. And then to get x by itself, I can divide by 5 or just multiply both sides by a 5th. So one possibility for x is 17/5. And if I plug 17/15 back into this, that will work. And this doesn't have 17/15 as a solution. That doesn't have 17/15 as part of the solution. Okay, 17/15 works, and it's part of this one. So I don't even have to do that second chance, that second one there. By process of elimination, it's going to be C. Okay. All right, so let me go with this one. So for that one, we're going to have 2x plus 8 is less than 9, and it's contained in here. So now I want to get x in the middle by itself. So I'm going to have -17, and 9 minus 8 is 1, and then divide everything by 2. And so I'm going to have -17/2 is the lower limit, and a half, and the endpoints are not reached. So I'm going to have D. Okay. And let's keep going down. Now for this one, we have two cases. So I'm going to have x plus 1 is greater than 3, and then I'm going to have x plus 1 is less than negative 3. So this is going to tell me x is greater than 4. Okay. Oh, sorry, I have to subtract 1 from both sides, not add 1 to both. Subtract 1 from both sides. And then I subtract 1 from here, x is less than negative 4. So I need these two in there, and I've got C. All right. And let's keep going. F of negative 3. Where is negative 3? It's in here. You can only use that because x is equal to negative 3. So that's the formula I'm going to use. That's going to be negative 3 minus 1, and so the answer is negative 4. And then I'm going to come down here. This is f of x equals 4 when it's between negative 3 and negative 1. All right, it's going to be that one there. That is possible, and that's not. That is possible. Now, between negative 1 and 0, this is going up. It has positive slope. Okay, and we have the endpoints. Okay, so that's true for both of those. And then for this one, the left endpoint's not there, the right endpoint is. And from the symbols here, it's going to be that one. So the answer to that one is B. B, B, B. Okay. So I got in just on time. Okay. And so that's going to be the end of this test. Got in just by the skin of my teeth, but I did start late. And I got 100. I forgot to put that on there. I finished too early. Okay, so all those answers are correct. Okay, so I can do a little bit more explaining on this one now that not under time constraints. So if it's a horizontal line, it's x equals a number, y equals a number, sorry, and the number's 4, and it's when x is strictly between negative 3 and negative 1. So that was true, and that one's true. But that's not the right section. Then for this part, it's a line and its slope is positive, so the number times x has to be a positive number. And we include both endpoints. So we have inclusion on both endpoints, so it's in between negative 1 and 0, and these were actually the same. But now when I came to this bit, it's a line, but you can see the left endpoint is hollowed out and the right endpoint is filled in. And so at 0 it's not contained, but at 1 it is. And these were not the right one. This would have been, that section would have looked like that with those constraints. Okay, so the answer was B. Okay, so that finishes that, and we'll stop the video.